Welcome to Video Consultations. In this consultation we're looking at Tutorial 8, Problem 7. Let's have a look at it. If x and y are independent random variables, each having probability density function given by this formula here, find the probability density function of z, which is the sum of x and y, and sketch its graph. Well, let's have a look. We've got a probability density for the random variable x, which is going to be 2x for x between 0 and 1 and 0 otherwise. The density for y is exactly the same. So x lies between 0 and 1, y lies between 0 and 1. And so one thing we should sort of note immediately, I think, is that x plus y has to lie between 0 and 2. And that tells us straight away that if we're interested in the PDF for z, that is the PDF of x plus y, it's going to be 0 for z less than 0, and it's going to be 0 for z greater than 2. So that just leaves us trying to figure out what the functional form is for it for z values between 0 and 2. Okay? It's the sum of two numbers between 0 and 1. It must lie between 0 and 2. It'll be important later that we've realised that there is the range of z values lies between 0 and 2. How would we tackle this problem? Well, there are two main methods that you could use, and we're going to look at each one individually. So method A is to say, well, it's just the sum of independent random variables. I can use the convolution formula to calculate the density. And what it does is it tells me that the density of the sum of x and y at a point z can be written as the integral from minus infinity to infinity of the density of x at z minus y times the density of y at y integrated over y. It's just a formula that we can know and we can quote. This formula involves, if you like, using the marginal distribution for y. The problem is symmetric. We're just adding x and y. X plus y is equal to y plus x, so we can relabel these or add them up in the opposite direction, and you'll get this formula here, which is equivalent. We'll be using the marginal density for x in this one, so I'll change the dummy variable in the integral, and over here, instead of the density for x, I have y, and I have just simply z minus x. Either of these formulas will do to use the convolution, to calculate it using the convolution formula. Method B that we're going to look at is called the distribution function method, and you've seen a number of examples of this in lectures, and basically what it says is let's try to find an expression for the distribution function for the sum. That's simply the probability that z is less than or equal to z, and we know that if we're dealing with a continuous random variable, when we differentiate the distribution functions, we will obtain the probability density function. Okay, so we've got to try and find the probability that x plus y is less than or equal to z. What I'd like you to do is to try method A before you come back to the next video. Be very careful when evaluating this expression here. you have to be very careful with the limits of the integration. So try to think very carefully about that. It's a very common error in a problem of this sort. See how you go, and we'll come back in the next video. We'll go through this problem using the convolution formula.